go over it. Or at least going to talk about the Earth as a magnet today. Electromagnets might have to wait till tomorrow. All right, so if we look at question 1. Let me pull this up on this. Minimize that for a second. All right, so if we look at the top boxes, based on the pictures you drew with your magnets, what we need to go right here? South, right? Because these lines are showing what? Attracting or repelling? Repelling, so you know they have to be the same. So that has to be a south and a south. What are these showing? Attracting, so that has to be a south and a what? A north. Would you be okay with that on the test? Okay. Number 1, what generalizations can you make about the reaction between like poles? Like poles do what? They repel. What generalizations can you make about unlike poles? They attract. All right, so on number 3, I asked you to draw the iron filings. So what can you tell me about those? They attract, right? So how should you have drawn your iron filings?
Like this.
In here, John. Okay. All right. He's got his little circles going there. And so he's got attracting. Okay. Number 5. Where would most of the iron filings be located? I know we didn't say at the ends. What do we call them? At the poles. If you said at the ends on the lab, I will take off -1 every time you said that. We call them what? Poles. All right, most of the iron filings, we did that. Where would, I did say that. Where would the iron filings be the most spread out then? The middle, because that's where it's the weakest. It'll be the most spread out in the middle. All right, what can you infer about the strength of the magnetic field based upon the position of the iron about the position of the iron filings? The poles are the strongest, the middle is the weakest. As long as you said the poles are the strongest, that would be fine. But the middle is where it's going to be the weakest. All right. What types of materials make good magnets? Ferromagnetic. All right. What are some examples of those? Yes. Is the magnet above permanent or temporary? Permanent. Now, if you can answer all of those, then you understand what we did yesterday. If you could not answer those, then you are not able to do what we did yesterday. If you need your notes to do those, you need to study some before we do the quiz on Friday. Okay? Now, based on the amount of time that we have left today, we should easily be able to talk about the Earth as a magnet. The electromagnet topic, best guess is we're going to need to hold that one till tomorrow. We'll just see based on what time they're going to ring the bell. It's supposed to ring at 1. Don't be shocked if they don't ring it at 1 because they'll have to reset after second lunch for y'all's lunch. I don't know what they're serving, but whatever they're serving. All right. Now, we're going to talk a little bit about the Earth as a magnet. Tomorrow, we'll do another lab on electromagnets. You're going to make one. And then Friday, we'll do electromagnetic induction, review for the test, and then the test is Monday. I told you, magnets is an incredibly short topic. And then we'll finish with waves, and then we're off to the chemistry section. Sorry, we're reviewing for the test on Friday. The test is Monday. All right, so what is magnetite or lodestone? Magnetite or lodestone is just a magnetic rock found in the earth. Okay? And I actually have one of them back here on my tub. I left it out so that when we got to this, I'd be able to pass it around so you can see it. Okay? I have, I'm pretty sure it's lodestone. The tag has fallen off over the years. Just pass it around. All right? But it is a rock. All right? And if you dig it up and stick it on a magnet, it will stick. All right? If you use a steel shovel and you stick the steel shovel into rock that is lodestone, what happens to the steel shovel when you stick it into that kind of rock? It sticks to the steel shovel. Okay? Now, I need you to draw that picture. Because we're going to label it and talk about it. Now, you can see that the bag's gotten kind of dirty as you're passing it around. That dirty bag, or dirty parts in the bag, are the iron filings that, of course, are coming off the rock and sort of making the bag dirty, just like it made the counter dirty or your fingers dirty as you worked with the magnet lab also. So, all the same stuff. And I keep it in the bag just so the pieces don't fall off and make the desk and everything else nasty. Now, as you're drawing, notice I have labeled the poles in two ways. Okay? I'm drawing the Earth. This is what that's supposed to be, by the way, the Earth. All right? This is supposed to be the equator. Okay, that's the equator. And then I've labeled the geographic North Pole and the geographic South Pole. Now, at the geographic North Pole, okay, I'll just write Santa there, because that's what, we all typically visualize as Santa's house, not that any of us believe. Claus. All right, the geographic South Pole. Okay.
If you don't believe, you don't believe.
That's true. Very positive way to look at it. All right, when I say the geographic South Pole, all right, the penguins live down there. So, those are the typical places that you guys learned about in middle school when you took geography, right? Your social studies teacher was teaching you about the parts of the world. Probably even talked about it in elementary school. Now, this long bar that I have sort of drawn here through the Earth.
You're an artist.
Yeah, I'm a real artist. Miss Thompson's fearful of her job right now. I was thinking the art teacher.
No, because she always does math.
Oh.
I feel like we do more math. Than
Thank
we
you.
do math classes.
All right, so the Earth has a bar magnet that runs through it, however. Now, this bar magnet also has poles, just like any other bar magnet. So, I have labeled those poles. Now, do those poles match the geographic poles? No. So, they're opposites. So, I've labeled those. Okay? Notice I gave those different names. I called this the magnetic South Pole and the magnetic North Pole. Okay? So that in hopes that we wouldn't confuse them, because I called them the magnetic poles, referencing the bar magnet that runs through the Earth. Okay? Are you with me on that? All right. So, does everybody have the picture? If a bar magnet hangs down from a string, okay, let's just say we take one of those bar magnets y'all have been using for 2 days, I tie it to a string, and I let it hang. When it stops spinning, what way will the magnet point? Any ideas?
Opposite way. As it can get north to south.
The north of the bar magnet will point where?
North out.
Will point to the North Pole. Okay?
We try.
The north on the magnet will point okay, let's try that again. Will point to the geographic North Pole. Okay? Go point towards Sandstone. Now, the north on the magnet will point to the geographic North Pole. Why will it point to the North Pole? Why does the north on the magnet point to the North Pole?
Because they love each other.
No. Think about what we know about magnets. A north is attracted to the magnetic South Pole, which is located at the geographic North Pole. I'll let you catch up and I'll point to it on the globe we drew. And I don't have to give you a string with a bar magnet because we can actually do it with something else.
Compass.
Yes.
Compass.
Yes. That's how it works. It's a magnet. Which is the next slide for today.
You have compasses.
Yes, I do. All right. Does everybody have it?
No.
Okay.
Almost done.
All right. So if we go back one slide and we look, if you have a magnet that's hanging from a string, a north pole is attracted to a what? You have a magnet that's swinging. That's a north and a south, right? This north is going to be attracted to a what? It's going to be attracted to a south. Where's the south at? The south is right here. The south is located at the North Pole. That's why it points to the North Pole. Now, what direction does a compass needle always point? Those of you who've had JROTC know this. Compass needles always point which direction? They always point north. The answer does not change from what you already wrote down. Compass needles point north. Why do they point north?
Magnetic.
What'd you already write down? They're attracted to the magnetic, say it, Alize, the magnetic south pole. If I go back 2 pictures, where is the magnetic south pole at? The North Pole. Okay? Compass needles point north. Why do compass needles point north? They're attracted to the magnetic south pole. The magnetic south pole is at the North Pole. That's why they always point north. Okay? So those of you who've learned how to read a compass in JROTC, that's why. They're pointing north because that's where the south is at. North and south do what to each other? They attract each other. Does that make sense? To anybody besides me in this room?
Yes.
Okay, Alize and I are together. What about the rest of you?
Yeah.
Okay, I know you want to go to lunch. You've had enough of being stuck in various places today. I get it. Altering schedules is tough. The rain we've had, it's dreary outside. It's tough. I get it. But are you with me? I didn't lecture for an hour and a half today. I mean, first period, I'll get pissed at me. They listened to me for 10:30. Yeah. Oh, yeah. Why that long? Because we're 3 days behind in chemistry thanks to the hurricane. So I made up an extra 45 minutes today. So they got a day and a half. All right. So
You made up her time.
I made up a half a day. I can't make up 3 days, but I can make up a half a day. All right. Any questions? So tomorrow we'll do electromagnets. Trying to be absent. We're gonna miss a lab. We'll take a quiz on Friday that's short, like multiple choice, 10 questions short. And then we're testing on Monday. Okay? That way we don't test on Tuesday, because I know you probably have a lot of other tests on Tuesday. But our test will be on Monday.
Should have let go until they left.
Even I'm not that cruel.
Okay.
And I'll be here for a little while today. If you want to do any makeup work.
I just-